there's a huge amount of value contained within a blockchain. We like to call it, we think of it as a dynamic transaction network, and the use cases for the data that you can get from that can be applied to understanding how the ripple effect of a risk event. We recently did a report on the Viper exploit. You could also understand user behavior. There's lots of different value points, but so the information that we have would be useful for people focused on MEV is the first obvious use case. So, for example, wallets, OFAs, searchers, block builders, they find our information and data very, very valuable.
Yeah. Considering your competitors, what do you do to maintain an edge in the market, specifically with MEV?
Well, actually, our edge revolves around the way that we do the analysis. So we do dynamic analysis rather than static analysis. And so we actually think that the fundamental element of a blockchain is a transaction. And what that means is that we understand the function of addresses from the transaction rather than trying to understand the transaction from like a static understanding or labeling of the address. And that gives us a very big picture of what we call a dynamic transaction network, and how that's the relationships between these transactions hold a huge amount of information. So a good example of that is essentially how we get to understand like the ripple effect that an event might have on the entire network. So what makes us different is the algorithms that we use and the technology that we employ. So one of the big things is that a lot of people still rely on old technology. So SQL is from the 1960s, but it's heavily still relied on. And once you get to a big data size, that can start to cause problems in accuracy of data. So one of the main differences is that we purposely built our algorithms to be able to serve the demands of the amount of size and the complexity of data held, of transaction data that is held on chain. And so there's three different parts to that. One is the size of the data, the growth of the data, and the dynamic relationship of the data. So we have three bespoke proprietary algorithms that simultaneously tackle those problems.
Very cool.